All right, guys, today we are doing 4.3, solving systems by substitution. And so there are three main types of equations, systems, that are best solved when you have substitution. And so you can see here that these are used when you have equation or equations. So if one or more of the equations already starts with y equals or x equals, you want to use substitution. It just makes your life easier. And so the goal is to put the equations together so that there's one variable to solve for. So you can't solve for x and y at the same time, so you have to solve for one or the other. So you can see in this first one that y equals 3x, the y is already by itself. So that means that we can substitute that into the other equation. So we're going to take what y equals 3x, and we're going to substitute it in for that y that's in that other equation so that there are no y's in that equation. So when I rewrite that, I'll have x plus 3x equals negative 32. So see, no y's. Now I can do that because the top equation told me y equals 3x. So if this y equals 3x, this y also equals 3x. So I can substitute them. Think about when you have a teacher who has a substitute. They're not there while that substitute is there. So y cannot be there at the same time as 3x because you're substituting. So then you've got 1x plus 3x, so you have 4x equals negative 32. And then just like a regular one-step equation, you're going to divide both sides by 4. X equals negative 8 because negative 32 divided by 4 is negative 8. So now we know that the x part of our solution is negative 8. No graphing required. Then to find the y, we're going to substitute this negative 8 for x in that first equation. So if we know x equals negative 8, then we can say that y equals 3 times negative 8, substituting. And so then if you do that in your calculator, I did get a new calculator, so hopefully this one will be a little nicer. Y equals negative 24. And so then that is your y part of your solution. And you're done. So sometimes substituting is a lot faster than rearranging, graphing, finding the intersection, all that stuff. All right, on this one, you can see that x is the one by itself, and we are told that x equals y minus 3. So that means in type 2 that you are going to substitute this whole expression for the variable that it equals. So instead of having x in this second equation, we're going to substitute y minus 3 in its place. That way, we only have y's to solve for in this equation right now because we can't solve for them both at once. Now notice how I put y minus 3 in parentheses. That's because, so sorry, I let my iPad fall over. Y minus 3 has to replace x as a whole. So that means you're going to have to put parentheses so that you remember to distribute your 3. Okay, it's not just 3 times y, it's 3 times y and 3 times the negative 3 because together they replace the x. And then you still have plus 4y equals 5. Now we're going to combine these like terms. So 3y plus 4y is 7y. So you have 7y minus 9 equals 5. And now you just have a two-step equation. So you're going to add the 9 to 5. And you're going to have 7y equals 14. And then divide by 7. y equals 2. 14 divided by 7 is 2. So that means that you know the y is 2 for this solution. Notice that I put it in the second spot because it's y, not x. Then you're going to substitute y equals 2 into that first equation where y is so that you can find out what x is. So I'm going to do that up here at the top because I've let myself run out of room. So that means I'm going to have x equals 2 minus 3. Well, you can just put that in your calculator because there aren't any variables on that side. So 2 minus 3 is negative 1. So that means my x coordinate, let me make that the same color, is negative 1. So the solution for this would be negative 1, 2. Makes sense? Now, type 3, these are already both in y equals mx plus b form. So these would be really, really easy to put into your calculator because they're already in the right form. So I'm going to type them in, and we're going to look at them both in the calculator and when we do the work. So when we graph that, that's what they look like. You can see, oh, I thought I could zoom that in. Let me try this. Oh, that's not going to help. It's not going to zoom it in. Nope. Oh well, that's fine. We'll leave it like that. So you can see right here that they cross each other at 1, 2. So we know that our solution should be 1, 2 by looking at the graph. But sometimes you don't have a graphing calculator, or sometimes some people just don't like using a graphing calculator. This type of equation, now you should have seen this before because I know that this type is the type that you do in 8th grade, because y equals both this and this expression, then that means those two expressions equal each other, because y has to equal y. So if y equals negative x plus 3 and y equals 4x minus 2, that means negative x plus 3 also has to equal 4x minus 2. Those are just the math rules. So I'm going to subtract the 4x because I like my x's on the left. If you do it the other way, that's fine. So you get negative 5x plus 3 equals negative 2. And then I'm going to subtract the 3. So I'm going to get negative 5x equals negative 5. Divide both sides by negative 5. Negative 5 divided by negative 5 is 1. That's correct. We know that because of our graph. So now we know x equals 1. And then it doesn't matter which one you put it in, but you have to substitute your 1 back into one of those original equations so that you can find y algebraically. So I'm just going to put it in this second one. So you're going to have y equals 4 times 1 minus 2. And then you just come over here to your calculator and you do 4 times 1 minus 2. Type it in just like it looks, and the answer is 2. Well, we knew the answer needed to be 2 because we graphed it. Sometimes, like in this situation, some people would rather graph. Some people would rather use substitution. So I'm just showing you that both methods work for this, for any of these equations, as long as y is by itself. The other two, since y, so like type 1, so y was by itself in the first one, but not the second one. So this one was an easy one just to use substitution because you didn't have to rearrange anything and put it in the calculator. And type 2 had x by itself, which you notice on the calculator, x is not by itself. It's always y. So we couldn't have used either one of them the way they were. All right, so from now on, I'm just going to use substitution and not graph But understand that you could graph these, or you could check your work by graphing these if you wanted to. On this first one, y equals x minus 1. So that means that x minus 1 can be substituted in for the y in the second equation. So I would have x plus 4 times x minus 1. Make sure you put what you're substituting in parentheses. And then you're going to distribute 4. Remember, 4 times negative 1 is negative 4. Then you have 1x plus 4x is 5x. So you have 5x minus 4 is 16. Now this is just a two-step. We're going to add the 4 to 16 and get 20. So 5x equals 20. Then we're going to divide by 5. So x equals 4. So we know our x value for our solution is 4. Then I'm going to take the 4 and substitute it back into this smaller problem. I'm using the smaller one because y is already by itself. So that means that when I write this down, I'm going to have 4 minus 1. And so I don't have to do any rearranging. All I have to do is 4 minus 1. 4 minus 1 is 3. So that means my solution is 4, 3. So if you do very much math, you will find that math people always choose the easiest route. So that's why I'm going to substitute that back into the easier equation, because it's easier. I want to do it the fastest, most efficient way I can. Okay, this is one of those type 3 problems where both of these expressions equal y, so that means they have to equal each other. So I can do negative 3x minus 3 equals 2x plus 2. I'm going to subtract my 2x. So negative 3 minus 2 is negative 5x. Bring down minus 3, bring down 2. Now I just have to add 3 to 2. Negative 5x equals 5. Divide both sides by negative 5. 5 divided by negative 5 is negative 1. So now I know that my x is negative 1. And then I'm just going to substitute that back into whichever one of those problems. It doesn't matter. Some people like to always use the top one. I'm going to use the top one. But then I'm just going to type this part into my calculator because that will tell me what y is. Now make sure that you use your parentheses, that you've substituted correctly, and that you type it in the way it looks. All right, so this one, the y equals 0. And y can equal 0, y'all. It doesn't matter. Some people think, oh, if I get a 0, it's no solution. No. 0 can be a solution. You can have $0. So make sure that you don't overcomplicate this by thinking that a 0 means something other than a 0. Now on number 3 right here, this one is one where you have a horizontal line because there's no x in the top. So because of that, that means that y equals 5. So we already know what y equals. You don't have to figure that out. So we're just going to substitute the 5 in for y in the other equation and find x. So number 3 is a really simple one. You just have to add the 5 to the 1. So x equals 6. And that's it. You're done. Because it told you y was 5. So this one definitely is easiest to solve by substitution. And then finally, number 4 is like type 2. So we're going to substitute this whole expression in place for this x. So that means we're going to have 4 times y plus 1. Remember, when you substitute, it goes in parentheses. So then we have to distribute the 4. And then we're going to combine like terms. Then we're going to start solving. So we're going to subtract the 4. So we get 6y equals 6. 10 minus 4 is 6. And I'm going to have to go up here. Then you have 6y equals 6. You're going to divide both sides by 6. Well, 6 divided by 6 is just 1. So that means that we know y equals 1 in our solution. Then you're going to take your 1 and substitute it into y in that top equation. Why am I choosing the top equation? Because that's the easier equation to deal with. So I'm going to have x equals 1 plus 1. Well, 1 plus 1 is 2. So that answer is 2, 1 for that solution. All right, so that's what your first page should look like. But wait, there's more. So we've got some more on here, and there's some on here with special solutions. I am going to do just a couple more of these, only because, as you can see, some of the numbers get a little bit bigger. So I'm going to do 5 and 7. 6 is still an easy one because it has y equals 4. It has that horizontal line, so you just have to put 4 in right there for y. So I'm not going to work that one. And then number 8 is a lot like number 7, but number 7 has bigger numbers. So I'm going to do 7, and then you guys look at it to do 8, and we'll check these in class. All right, so for number 5, I'm going to substitute this whole thing in for y. Okay, it tells me y equals all of this junk. So I can replace y with all of that junk. But then I have to remember to distribute the 4. So negative 4 times 6 is negative 24, and negative 4 times 20 is negative 80. Then I'm going to combine these like terms. So that's 7 minus 24. Oh, goodness, I hit the wrong button. So that's negative 17. X minus 80 equals negative 12. Then I'm going to add 80 to negative 12 so that I can get negative 17x by itself. So then I have negative 12 plus 80. That is 68. Then I'm going to divide both sides by negative 17 and hope that that's a whole number. And it is negative 4. So I know x equals negative 4. So that means up here in my solution, I'm going to have negative 4 for sure. Then I'm going to take this negative 4 and substitute it in to the first equation in the spot for x. Y is already by itself. Y is what I need to find. So that's why I want to substitute into the first equation. You can substitute into the other one and still get the right answer, but it's going to be harder. It's going to take more work. So this one, because y is already by itself, and after I substitute, there are no numbers left in the expression, I can type that in just like it looks, and it gives me my answer for y. So y is negative 4 as well. So my solution for this one is negative 4, 4. All right. On this one, I've got the fact that x equals 24 minus 3y. So all of that business needs to go in and replace the x. So I'm going to have negative 3 parentheses 24 minus 3y. Oh, whoops. Oh, plus 3y equals 0. I left this guy out. Don't do that. So, and it can equal 0 like that. That's fine. Remember, 0 is a number. So I'm going to do negative 3 times 24, and that is negative 72. And then negative 3 times negative 3 is positive 9. And then I just bring down plus 3y. Okay, you only multiply with what's in parentheses. You don't just keep going. Then these guys are like terms. So I'm going to have negative 72 plus 12y equals 0. 9 plus 3 is 12. Then I'm going to add the 72 to 0 so that I can start getting y by itself. 72 plus 0 is just 72. And then 72 divided by 12 is 6. So now I know in my solution box, I'm going to have 6 for y. Then I'm going to take 6 and substitute it back in for that y in the top equation so that I can find x. So x equals 24 minus 3 times 6. This can go into your calculator. 24, delete, minus 3 times 6. Remember to substitute with your parentheses, and I get 6. So this solution is 6, 6. Okay? So you're going to use this information to do 6 and 8 over here. Now, let's look at some of these special solution ones. You are going to do the same thing, but the reason that we need to practice these is so that you know what to do when you get a strange answer. So just like before, we're going to substitute in 8 minus 3y for x because it tells us x equals all that stuff. So I substitute that in with parentheses, distribute. And then when I combine these like terms, negative 9 plus 9, that's 0. Well, 0y means there's no y for this problem. So this is telling me 24 equals 24. Does 24 equal 24? Yes, it does. So if they equal, if you get the same number, it's an infinite solution. So that's good. That's what we want. Let's look at number 11 and see what we get. So this time we're going to substitute negative 3x for y because it tells us y equals that. So that means this y also equals that. So we have 9x plus 3 times negative 3y equals 3. Lots of 3's. 3 times negative 3 is negative 9y. 9, oh, I left the y and I meant to have x. This should have been an x. Did you guys catch that? Were you thinking I was crazy? When I substituted negative 3x for y, I didn't write it correctly. So it should have been 3 times negative 3x. 3 times negative 3 is negative 9x. 9x minus 9x is 0. Does 0 equal 3? No, it does not. If you get different numbers like this, then it is a no solution because that's not true. So it can't possibly be correct. So make sure you don't get those mixed up. When we did this before and we had things like this, a lot of people they either thought they were all infinite or they were all no solution. That's not true. If they are the same, then it is infinite solution. See, if they are different, then it is no solution. So make sure you're keeping that straight in your brain. All right, so it looks like over here we would probably have one apiece of those again. I'm not sure, but go ahead and work them out on your own along with 6 and 8. So you guys do 6, 8, 10, and 12, and we'll look at them in class together.